Our syllabus calendar up on the board here. We're starting our lessons, a series of 3 lessons on transformations of functions. So we've got 3 lessons on this one topic. It's kind of a bear. You'll struggle through it a little bit. It will take some time for everything to sort of settle and make sense. Just work your way through it, and I promise by the end of next Friday, like it'll start to feel like it's coming together. Okay. So, and then we don't have any other assessments or things due until quiz 3, which will happen on the 19th. And then also project 2, it's not due till the 26th, but it's about the topic transformations of functions. So I will give you that project today. You can kind of have it with you, read through it, have it in the back of your mind as we work through these 3 lessons. Okay, I'll hand those out. All right, so I'm actually going to have us skip the preview exercises for right now. If you finish class a little earlier, then you can go back and do these after. But we're going to jump to the demo. Hey, I'm waiting for you. Thank you. Okay, I want to graph f of x equals x squared by hand. So anytime you are asked to graph something by hand without using technology, either you just know what it looks like and you can draw it, and if you don't, you just plot a bunch of points, right? So that's what we're going to do. We're going to make an x-y chart, right? Instead of y, I'm going to use our new terminology that we've been learning lately, f of x. So let's do like -4, -3, -2, -1, 0, 1, 2, 3, 4. So I'm just going to plug each of those x values into x squared to get my f of x value or my y value. So I get 16, 9, 4, 1, 0, 1, 4, 9, 16. And I can plot them. -4, 16, -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9, and 4, 16. And then we'll just connect them with a nice smooth curve. And that should look pretty familiar, right? That's the graph of y equals x squared. You should hopefully have seen that in some previous class. Okay, so now I'm going to graph each of the following using my graphing calculator. Okay, so rather than do it by hand, I'm going to have my calculator help me. I have calculators for each of you, so let me hand those out so you can follow along on your own calculator. Okay, so I've got my my graphing calculator up on the screen here. And so I will walk you through how to graph these things on your calculator. If you're using Geogebra, I can show you how to do that too. So we'll do it on the calculator first, then Geogebra. All right, so for the calculator, we go to y equals. If there's anything in there, clear it. If plot 1 is highlighted up in the upper left, if you see plot 1 looks highlighted like that, you want to turn the highlighting off. Just put the cursor on it and press enter so it's not highlighted. And then we're just going to, in y1, type x squared plus 3. X squared plus 3. And then I'm going to press, I want to use the same window that I have, that I graphed this on, so that I can get an accurate picture when I copy it. So I'm going to go to window, and I went -5 to 5 for x. And for y, it looks like -6 to 16. So there's my window, and I'm going to press graph. Okay. And compare how that picture looks to my picture of just plain old x squared. how does it look different? It's above the origin. Yeah, the whole thing got moved up a little bit. If you want some points, you can look at your table and you could plug in the same x points that we had before. Maybe I'll just start at -3. 1, 2, 3. And now we have the y's over here. So I'll do this one in a different color. So I've got -3, 12, and -2, 7, -1, 4, 0, 3, 1, 4, 2, 7, and 3, 12. So if I connect those with a nice smooth curve, there's my new graph. So this is, I think I called it g of x equals x squared plus 3. This first one was just f of x equals x squared. Right? And then I also want to do x squared minus 4. So I'm going to go back to my back to my graphing calculator, go to y equals, and I'm going to just turn off the x squared plus 3. If you put the cursor on the equal sign and press enter, it leaves your equation there, but it just won't graph it. So then in y2, I'm going to put x squared minus 4. My window is already set. I already did that, so just press graph. And how does that graph differ from the original graph of x squared? Lower by 4. Yep. So if I need points, right, I could look at my table, or I could say, well, it looks like it did the same thing as x squared plus 3 did, where it moved everything up 3. Let's just take each point on x squared and move it down 4. So this point was at -4, 16, so it would end up at -4, 12 if I move it down 4. And then this one, -3, 9, is going to become -3, 5. Move it down 4. -2, 4 becomes -2, 0. And -1, 1 becomes -1, -3. 0, 0 becomes 0, -4. And then these guys, I can use symmetry to just fill in the other dots because they're at the same heights. 5, 4, 12. So this is, I think I called this h of x is x squared minus 4. All right, so in our own words, we want to describe what happened to the original graph f, which was just plain old x squared, to get each of the new graphs. Has the graph been moved left or right, horizontally, or up and down, which is vertically? So to get the graph of g, the graph of f, you already told me moved up 3 units. I just moved the whole graph up. Okay. To get the graph of h, we moved the whole graph of f down 4 units. All right, so f of 0 was 0. And you can see that in the graph or from my original table. F of 0 is 0. G of 0, if we look at my formula, if you plug a 0 in there, you get 3. And h of 0, if you put a 0 in for x, you get -4. So we can see the relationship there, right? So f of 0 was 0. G of 0 should be 3 because we should add 3 to the y coordinate to move the whole thing up. H of 0 should be -4 because 0 minus 4 is -4. Let's see if the relationship holds for -2. Okay, f of -2 would be what? 4, because -2 squared is 4. G of -2, if you put a -2 into this formula, you get 7. And h of -2, put a -2 in here, and you get 0. So let's see if this holds. So it should be that if I add 3 to my f of x value, I get my g of x value, right? 4 plus 3 is 7, right? And I should be able to subtract 4 from my f of x value and get my h of x value. And 4 minus 4 is 0. Okay, what is the domain of f? So f of x is x squared. What kind of x values can you plug into that formula? All of them, yeah. There are no restrictions on x squared. Remember, domain, your only restrictions happen if you have a fraction, you got to make sure the denominator is never 0. Or if you have a square root, you got to make sure you're never taking the square root of a negative. So the domain for f is going to be -infinity to infinity. Okay. How about the range for f? What y values can you get as a result? 0 to infinity. 0 is the smallest y value you get. And it is included because 0 is actually a y value on the graph. All right, how about g, which was x squared plus 3? Any restrictions on its domain? No. So this is -infinity to infinity. You can plug anything you want into x squared plus 3. What's the range? 3 to infinity, yeah. The range, the smallest y value is 3, and it goes up to infinity. Okay. And h, x squared minus 4, any restrictions on its domain? Nope. -infinity to infinity. How about its range? What's the smallest y value to its biggest y value? -4 is its smallest, and it goes up to infinity. Okay. So my transformation, right, my +3 and my -4, did they change the domain at all? No. Did it change the range? Yes, my range is what changed. Yes. So because, and that makes sense because what changed were my y values. My y values all had 3 added to them or 4 subtracted to them, and range measures y values. All right, so we're going to rewrite g of x and h of x as a transformation of f. So remember, f of x is x squared, and the transformation, that +3 is my transformation, the -4 is my transformation of the function. Those two things happen after squaring, right? So because of the order of operations, you would square the x, then add the 3, right? So this changes the output only and always result, which is the y, it changes the y coordinate only and results in a vertical transformation. So x squared is f of x, right? So if I wanted to write this in terms of f of x, right, that's what I'm asking you to do. That means I want you to have f of x in the formula. So you're going to replace the x squared with an f of x. So it's just f of x plus 3. And then for h of x, which is x squared minus 4, we'll rewrite that as f of x minus 4. We're going to apply the transformation to a few points on f. So these are some random points on f. Just grabbed them from the table from when I graphed by hand. And we're going to apply the transformation to get a few corresponding points on g. Okay. So if this says g of x equals f of x plus 3, remember f of x is just our new fancy notation for y. So that says my new function, it just takes all the y's and adds 3 to them. So -2, 4 would become -2, 7. Just add 3 to the y coordinate. -1, 1 becomes -1, 4. 0, 0 becomes 0, 3. 1, 1 becomes 1, 4. And 2, 4 becomes 2, 7. So the x's are not changing at all here. The only thing that changes is the y's. And when y changes, that's going to create a vertical change in the graph because y measures the vertical location of a point. All right, so that is vertical shifting. So I'm going to have you start some activities, and you're going to do a little bit more with vertical shifting, but with a different function, square root x instead of x squared. So you're going to do kind of what we just did. And then after that, you're going to get to, you're going to go back to x squared, and you're going to look at a different kind of transformation. Okay, so you will just work through it. You might not see the big picture until you get through all 3 classes, but just keep working at it and ask me if you have questions.